to the Chemistry 124 demonstration videos. This video will be involving Practical 2, which is about limiting reactions. During this practical, you will react hydrated copper chloride with aluminium in two different reactions. In the first reaction, you will use the hydrated copper chloride in excess, and in the other reaction, you will use the aluminium in excess. Now, why is this important? Well, when you write out your chemical reaction equations, you normally write them with the ideal stoichiometric ratios of reactants to products. But in real life and in the lab, you don't always have a stoichiometric mixture of your reactants. One of your reactants will be in excess and one of the reactants will be limiting. The excess reactant is the reactant that is left over at the end of the reaction, and the limiting reactant is the one that is completely used up during the reaction. Now this is important because the limiting reactant is what you use to determine the amount of product that forms.
You will be able to monitor the reaction's progress by evaluating the color change occurring in your beaker, as well as the formation of solid copper. The aim of this practical is to become familiar with reactions that involve a limiting reactant, be able to identify the limiting reactant based on the experimental results, and to compare the results with the expected theoretical yield by calculation of the percentage yield. The following apparatus, glassware, and chemicals will be required: a 600 cubic centimeter glass beaker for your waste, two 250 cubic centimeter glass beakers for your reactions, one 50 cubic centimeter measuring cylinder, one permanent marker which you need to bring from home, one plastic weigh boat, one glass stirring rod, one spatula, one 3 cubic centimeter plastic Pasteur pipette, 50 cubic centimeters of deionized water, aluminium foil, methanol. Remember, methanol is flammable, so keep it away from any source of ignition such as an open flame. And lastly, hydrated copper chloride. Hydrated copper chloride are blue crystals in flasks next to the mass balancers. Copper compounds are toxic irritants. Handle these compounds with care and wash your hands thoroughly after the practical session. These danger signs appear when picking up different chemicals. See your manual for what they mean. The method is as follows. Label one 250 cubic centimeter glass beaker as A and the other beaker as B. Weigh these beakers and record their masses in the data report table, which is found in your prac manual. Weigh approximately 0.50 grams of the hydrated copper chloride directly into beaker A and approximately 0.70 grams of the hydrated copper chloride directly into beaker B. Record the exact mass of the hydrated copper chloride in each beaker in the data report table. Weigh off approximately 0.075 grams of aluminium foil in the plastic weigh boat and report the exact mass of the aluminium in the data report table. Tear the aluminium into very small pieces and add this to beaker A. Weigh off approximately 0.050 grams of aluminium foil in the plastic weigh boat and report the exact mass of the aluminium in the data report table. Shred the aluminium into very small pieces and add this to beaker B. Now use the graduated cylinder to measure approximately 50 cubic centimeters of deionized water and add this to each of beakers A and B. Swivel the beakers or stir the beakers alternately with a glass stirring rod. The reactions should take about 30 minutes to complete. As the reactions proceed, record any observations that you see in the data report table. This includes color changes, bubbling, etc. If there is excess aluminium foil still observed in any of the beakers after 30 minutes, then add 6 molar hydrochloric acid, Hydrochloric acid is corrosive, so handle this with care. Add the hydrochloric acid in approximately 1 cubic centimeter portions and stir with your glass rod or swivel the beaker after each 1 cubic centimeter addition until all of the aluminium foil is completely reacted and no longer visible. Do not add more than 5 cubic centimeters to each beaker in total. Allow the solid copper to settle in both beakers. Carefully decant, pour off the liquid, the solution from each of the beakers into the 600 cubic centimeter glass beaker. Be very careful not to lose any of your precious copper. Wash the copper solid with approximately 15 cubic centimeters of deionized water. Let the copper solid settle again and decant the solution from each beaker again into the 600 cubic centimeter glass beaker. Make sure that you carefully decant as much as possible of the solution without losing any of your precious copper solid. Repeat this step once more. Wash the copper solid with approximately 10 cubic centimeters of methanol. Let the solid settle and decant the solution from each beaker into the 600 cubic centimeter glass beaker. Mark each beaker with your initials and place them on the hot plate in the nearest fume hood for 2 to 5 minutes until the copper solid is dry. Avoid heating for more than 5 minutes as this may cause unwanted oxidation of the copper. Do you have any idea of why oxidation of the copper would be problematic for your experiment? Place the beaker on a metal gauze and wait for it to cool. After cooling, weigh each beaker with its contents and record these masses in the data report table. You can weigh them as soon as they are lukewarm. Discard the copper in the waste container for solids that is supplied and pour the liquid from your 600 cubic centimeter beaker into the supplied waste bottle for liquids. In summary, you use these reactions to identify the limiting reactants and then you use the limiting reactant to calculate the percentage yield.